We are COMS, Carbon Dioxide and Oxygen Monitoring System. I'm DeBron Chouse. I'm Fulbert Joe.
I'm Juliana Pistona.
I'm Carlos Flores.
I'm Alejandra Perez.
So, here at COMS we have a vision. It's to monitor levels of carbon dioxide and oxygen to provide a safe work environment for all of you. Why should you use COMS? Well, COMS assures healthy O2 and CO2 levels. It does constant measurement, so you never have to worry. It's small and portable, so you can just place it somewhere. It's low cost, low power, and portable. So overall, COMS is a small device that you can take into a place such as a wine tank. Just place it down while you work, and it will continuously monitor those oxygen and CO2 levels. If at any time those levels become toxic, a small alarm will go off, warning you to move before it's too late.
Okay, and so for beta board, as you can see, we have the battery charger, which is over there, our buzzer, our step down, our step up, the USB, the battery connectors, and our CO2, our O2, and our XBs. Yes.
Here we are displaying our two sensors data. We switched out the case here here, but kept the oxygen the same. We've also added a buzzer to our system. The buzzer works as an alert once the CO2 levels and O2 levels become toxic. For CO2, we've set our toxicity level at 800 ppm. Here we'll display the CO2 causing buzzer to alarm. As you can see, the graph is increasing, and as it does, the buzzer sounds. In our code, we set it so that the buzzer turns off and back on, just to make sure that it's actually running. In reality, this is the continuous debugging until the system itself is completely turned off. Next, we will try and cause the buzzer to sound through the O2. The O2's level is below 208 millibars. And as the CO2 level goes back to its appropriate level, we will test to see that O2 won't go below 208 sounds the buzzer.
And this is our power. So we have the battery charger, the USB to charge it back up, and it's hooked up to a 3.7 lithium-ion battery, and then that goes into our step down and our step up. So the boost powers the oxygen sensor, and the regulator or the step down at 3.3 powers the XP, the PSOC, and the carbon dioxide.
So this is the digital communication of our system. We're communicating with oxygen sensor there, carbon dioxide, and XB all through UART. Also, it's not displayed here, but we're using PWM to run the buzzer.
So this is a CO2 sensor we decided to go with. It's very low power, as you can see. It measures well up to 5,000 parts per million. Since we have it set to 800, dangerous levels usually reach about 1,000, so we give them a little bit of leeway before the buzzer goes off. On its own, hooked up to our battery, it could last a minimum of 1,500 hours, so you can see it's very low powered. This is a Luminox oxygen sensor we chose. It consumes a bit more power than the CO2 sensor, but it's because it'll require a little bit more of a response time to gather the data. And because CO2 is more important for us to measure, this will be running about every 2 minutes, as the CO2 sensor will be running every 1 minute. So the power consumption, we can get about 300 hours minimum on our battery on its own. And this is a state machine for our design. Every 1 minute or so, the CO2 sensor would be testing, and of course, if it reaches unsafe level, the buzzer would go off, and it would continue to stay in the buzzer alert state until the user has reset the system. And then every 2 minutes, it'll test the O2, and then again, if that goes off, then it'll stay in the alert state until it is reset.
So this is a 3D model of our final board, release board. So our board size itself isn't that big, but the case we got is quite huge for our application. So we made it diagonal board. So we just made like a thin and long board to get the screw holes on the edges. So basically we are using the same system on the. Oh wait. Yeah, we're changing like some of the power options because of low quiescent currents, but the power line stays the same. We're still running 3.3 volts and 5 volts.
So, question on the state machine. You can go for the state machine. So it seems like it's your initial state, the top one, right? Yeah. So you have A0, B0. Has two edges outwards, one's a south loop and one goes down. How does it know which one to pick?
Okay, that's just a mirror on my part. So every 2 minutes it would be A, not B.
I think you need an initial condition in there somewhere. Like where does it start? Yeah, like where
Yeah,
does it start? And then on your release design mock-up on the end, is that straight down or?
Yeah,
Okay.
depends on how you place the hole on the box.
Oh, okay.
Provide better response.
Just clarify, the box too big, the box too small. I'm not quite sure when you say something about the box.
So our board is about 4 inches squared, while the box is about 16 inches squared. So
What would be the ideal situation if you have? Do you want a different box? Different what?
So we did try testing with smoke lounge as Nick wanted, but we couldn't get it because of thickness.
If you have
Ideal case would be finding a smaller box that matches that size.
okay. So which controls are you going to be using? This one for the first one, right?
Yeah.
On your slide with the sensor, oxygen sensor, and the CO2 sensor, very nice. Put the information in there, how long they're going to be on.
Okay.
Right? In terms of warm-up time and other stuff. So put that information in there. Excellent.
Once the alarm goes off, why do you have it afterwards? Why don't you have it keep reading so that they'll know when they're in the safe area?
So our goal was for them to exit the line tank,
Okay.
and once they exit, they could just flip the switch, turn the system on, so they know that it's leave. We could, I guess, move it on to make sure that the area of the access to the room is also safe.
Yeah, I think that's a good point. Users should not be switching things off, because they will switch it off when they go in the tank, so that they
Okay.
It should be safe when they leave the tank regardless, so it should regulate.
Yeah.
just keep it on. Supervisor couldn't turn it on. It would be really difficult for somebody to use it.
I think come up with the frequency of that alarm. I noticed like in the last Terry
Oh, it's
really
just a buzzing frequency.
very nice.
One more thing I thought of, it might actually draw more attention if it wasn't a constant tone. Sometimes if it's a constant tone, it can kind of go in the background. So maybe it would be good to like pulse it in and out. Pulsing on and off is usually more attention grabbing than the constant tone.
So that's exactly, if you know, the firefighters are there, the problem is